Hello everybody and welcome back to Unit 8 of Regents Chemistry, where we'll be talking about reactions and stoichiometry. Today we'll be talking about the molar mass. You guys will learn how to calculate the molecular mass or the molar mass of a given compound or element. So molar mass, quite simply, is just the total mass of any substance, whether that's an element or a compound, and it's also referred to the two other names for molar mass is gram formula mass and the molecular mass. So make sure that you guys are familiar with all three of those names. So if you ever have to calculate the molar mass of an element, that's pretty easy because you just go to the periodic table, you look at the mass number or atomic number, the mass number or atomic mass of that element, and that is the molar mass. But for a compound, we'll see in just a second how to calculate the molar mass of compounds. Now let's say this is a compound that's given to you and the question is asking you to find the molar mass of this thing, potassium carbonate. Now in this compound we have 2 atoms of potassium, we have 1 atom of carbon, and we have 3 atoms of oxygen, and we know that based on their subscripts. Potassium has a subscript of 2, carbon has a subscript of 1, oxygen has a subscript of 3. Now when we calculate the molar mass of this compound or the molecular mass of this compound, we just look at the mass numbers for each of the elements in the periodic table. We multiply them with the number of atoms and we add them all. So let's start with the potassium atom. You go to your periodic table, find potassium, and look at the mass number. We can round that to the nearest whole number, and then we multiply that with the number of atoms. So we have 2 atoms of potassium, so we do 39 times 2. Same thing with carbon, and we are going to add that to the previous one. So find carbon in the periodic table, find the mass number, which is 12.011. We can round that to 12, and then we do add that to the previous one and do 12 times 1. And then same thing for oxygen, find that in the periodic table, look at the mass number, and then multiply that with 3 atoms of oxygen that we have and add them to the previous one. Alrighty, and then we can just do the math, put everything in your calculator, take care of the parentheses or the brackets, and get your answer. So that turns out to be 138 grams. So the molar mass of potassium carbonate is 138 grams. So that's how you calculate the molar mass of a given compound. Now, this molar mass that we just looked at, or the molecular mass, is basically for the molecular formulas. So molecular formulas are when we have a formula or a compound with its actual ratio of atoms. So for example, here we have C4H10. That means we have 4 carbons, we have 10 hydrogens. So we just use that to calculate the molecular mass. However, we can have it other type of formula, and if you guys remember this from when we were talking about the writing the formulas and naming the compounds, so from chemical bonding chapter, we said that if we get a formula like this, like C4H10, we were normally simplifying that to a simpler form or a simpler formula or simpler ratio, and that new formula is called the empirical formula, which is the simplest ratio of the number of atoms of all of the compound of all of the elements that we have in a compound. So for example, the C4H10, if we have to simplify this, will make that C2H5. So the mass that we calculate based on this new formula, C2H5, will be called the empirical mass, not the molecular mass. So that's just one thing to remember. Your molecular mass is based on the molecular formula, where you have the actual ratio of atoms. Empirical mass is for the empirical formula, where you see a simpler ratio of atoms. Now, the reason why we talked about this empirical formula and empirical mass thing is because sometimes you are given the empirical formula and the molecular mass of something, and you are asked to calculate the molecular formula of that compound. And the equation that we use for that is this. We take the molecular mass, which is already given in the question, and we divide that by the empirical mass, which we can calculate based on the empirical formula. This gives us a ratio. We multiply that ratio with the empirical formula, and that gives us the molecular formula. So let's look at what that looks like in practice. Alright, so here we have a question. We are given the empirical formula, which is CH, and the molecular mass is 26 grams. We have to calculate the molecular formula. So the equation that we have to use is this, molecular mass divided by empirical mass. So for this equation, we are already given the molecular mass, which is 26 grams. The empirical mass, we don't know yet. However, we are given the empirical formula, which is CH. And we know how to calculate the molar mass, or the mass, using the formula. So we just go to the periodic table. We look at the mass number for both carbon and hydrogen. The subscript for both of them is only 1, which means we only have one atom right now. So for carbon, we do 12 times 1. And then we add that to hydrogen, which will be 1 times 1, because the mass of hydrogen is only 1. We do the math, and the empirical mass turns out to be 13 grams. So now we can just go ahead and plug the molecular mass and the empirical mass in the equation, which gives us 26 grams divided by 13 grams, and a ratio of 2. So now all we have to do to figure out the molecular formula is multiply this ratio with the empirical formula. So the empirical formula is CH times 2. And so the molecular formula that we get will be C2H2, because we just multiplied the CH, which we had 1 carbon and 1 hydrogen before. We multiply that with 2. Now we have 2 carbons and 2 hydrogens. So that is the molecular formula. And that's it for now, guys. Take care. I'll see you in the next one.